Hi everyone, welcome to our physics class. In the previous classes, we have studied about reflection of light. So in this class, we are going to discuss about the next a very important concept, that is refraction, refraction of light. So refraction of light means the phenomenon of the bending of light ray when it travels from one medium to another medium of different optical density. Okay, so what is the meaning of optical density? So that is very important. A transparent medium, a transparent medium in which the speed of light is less than in air. So that is the meaning of optical denser medium. For example, the glass is more optical denser than air. Compared to air and glass, the speed of light in glass is less compared to air. So the glass is optically denser than air medium. Okay, here first let us consider a plane refracting surface, that is x, y. So x, y is plane refracting surface, and then consider a normal. What is the meaning of normal? Normal is imaginary perpendicular to the given surface. So when a ray of light is incident at this point, let us consider that is O. O is the point of incidence, and this is AO is incident ray. So NOM. So this is normal at the point of incidence. So the angle made by normal to incident ray. What is this? Angle of incidence. And here this is the direction of incident ray. So the ray of light travel from rarer medium to denser medium. So what happens? The refracted ray bends towards the normal. So angle made by normal to refracted ray. Let us consider OB is a refracted ray. So this is the angle of refraction. Angle made by normal to refracted ray. So that is angle of refraction. So the angle made by direction of incident ray and direction of refracted ray. So this is the deviation suffered by the ray. Okay, so that is calculated by considering here two angles. So actually these two are vertical opposite angles. Okay, so I value, that is exactly equal to what is this? Total angle or plus D. Or plus D. So what is the value of D? D is I minus R. So this is the deviation suffered by the ray. So when a ray travels from rarer medium to denser medium. For example, this is air and this one is the glass medium. So ray of light travels from rarer medium to denser medium. So what happens? The refracted ray bends towards the normal. So the phenomenon of the bending of light ray when it travels from one medium to another medium of different optical density. So that is called the refraction of light. And it is of two very important laws. Number one, that is the incident ray, refracted ray and the normal at the point of incidence. Incident ray, refracted ray, and normal at point of incidence all lie in the same plane. Okay, the incident ray, refracted ray, normal at the point of incidence all lie in the same plane. That is the first law of refraction of light. The second one, the ratio of sine of angle of incidence. The ratio of sine of angle of incidence to the sine of angle of refraction is always a constant. It is constant for the given pair of medium and for the given wavelength of light used. Okay, the ratio of sine of angle of incidence to the sine of angle of refraction, it is always constant for a given pair of media and for the given wavelength of light used. So actually this is called Snell's law. This constant is called the refractive index. The sine I divided by the sine naught is equal to n. Constant is called the refractive index. The symbolic representation of refractive index is n or mu. So this is the symbolic representation of refractive index. So the refractive index actually measures the optical density of a transparent medium. So greater the optical density, greater is its refractive index. Smaller the optical density, smaller is its refractive index. So refractive index measures what? The optical density of a transparent medium. The standard value of refractive index of air, that is 1. Refractive index of glass, that is 3/2, approximately that is 1.5. And the refractive index of water, okay, that is 4/3, 1.3333. Okay. So refractive index, what is the significance of refractive index? Refractive index actually measures. Refractive index measures the optical density of a transparent medium. So refractive index, this is of two very important types. One is absolute refractive index and another one is the relative refractive index. One is absolute refractive index. So absolute refractive index, so it is the ratio of the speed of light in vacuum to the speed of light in a medium. The ratio of speed of light in vacuum to the speed of light in a medium, so is called the absolute refractive index, and it is always greater than 1 because the speed of light in vacuum, it is always more than speed of light in a medium. So absolute refractive index, it is always greater than 1. So this point is very important. So what is the meaning of absolute refractive index? So that is the ratio of speed of light in vacuum to the speed of light in a medium. Okay, and the next one is the relative refractive index. So when a ray travel from medium 1 to medium 2. So ray of light traveling from medium 1 to medium 2. For example, this is having refractive index is N1. So this is medium 2 having refractive index is N2. Okay. So ray of light travel from medium 1 to medium 2. So in that case, the relative refractive index, so that can be written in the form of 1 n2 is equal to n2 divided by n1. So relative refractive index means refractive index of one medium with respect to another medium. So what is the meaning of relative refractive index? Refractive index of one medium with respect to another medium. So in this case, Snell's law that can be written as n2 divided by n1, that is equal to the ratio of sine of angle of incidence to the sine of angle of refraction. Okay, right? Now let us consider a plane mirror. So that is placed here. So actually the ray of light incident normally. Okay, so here the ray of light is incident normally. So whenever the ray of light is incident normally on a plane reflecting surface, what happens? In that case, the angle of incidence is equal to 0 and angle of reflection, that is also 0. So after reflection, what happens? The ray retraces the same path, right? So here after reflection, the ray actually retraces the same path. So this is called the principle of reversibility. So this is also very important concept. Principle of reversibility. Principle of reversibility. That means the ray of light suffers. The ray of light suffers number of reflections and refractions. The ray of light suffers number of reflections and refractions. It retraces the same path. Okay, ray of light suffers the number of reflections and refractions. It retraces the same path. So that is the statement of the principle of reversibility. So ray of light traveling from medium 1 to medium 2. So Snell's law, so that can be written in the form as that is 1 and 2, that is equal to n2 divided by n1. So that is equal to sine I divided by sine R. Okay, so when a ray travel from ray of light travel from medium 2 to medium 1. Ray of light travel from medium 2 to medium 1. So ray of light travel from medium 2 to medium 1. Ray of light travel from medium 2 to medium 1. So in that case, Snell's law, so that can be written in the form 2n1. That means the ray travels from medium 2 to medium 1. So 2n1, so that is equal to n1 divided by n2, so that is equal to sine. So ray traveling from medium 2 to medium 1. So in that case, R is the angle of incidence, I is the angle of refraction. Okay. So Snell's law becomes 2n1, that is equal to n1 divided by n2. So that is equal to sine of angle of incidence. So here R is the angle of incidence, I is the angle of refraction. So sine R divided by sine I. So call this as equation number 2. Okay, so call this as equation number 1. So absolute refractive index, it is always greater than 1. But the relative refractive index, it may be more than 1 or less than 1. That depends on the ratio of what? Refractive indices. So if N2 is more than N1, so in that case N2 divided by N1, that is more than 1. Okay, so actually here N2 means the refractive index of glass, N1 means refractive index of air. So here N2 is more than N1 because N2 is the refractive index of glass, N1 is refractive index of air. So refractive index of glass is more than refractive index of air. So that is why N2 divided by N1 is more than 1. But here N1 divided by N2. So what is the meaning of N1? N1 is refractive index of air. So N2 is refractive index of glass. So refractive index of glass, that is actually 1.5. Refractive index of air, that is 1. So 1 divided by 1.5, so that is less than 1. That is less than 1. So relative refractive index, it may be more than 1 or less than 1. That depends on the pair of optical density. Okay, pair of optical density. So now equation 1 and 2, equation 2 becomes equation 1 and 2, equation 2. That is 1 and 2 into 2 and 1. So that is equal to sin I divided by sin of into sin of divided by sin I, right? Sin I get cancels, sin or cancels. So 1 and 2 into 2 and 1 is 1. So 1 and 2, that is equal to 1 divided by 2 and 1. So this is the mathematical expression for the principle of reversibility. Okay, so relative refractive index means refractive index of one medium with respect to another medium. Absolute refractive index means the ratio of the speed of light in vacuum to the speed of light in a medium. So relative refractive index means refractive index of one medium with respect to another medium. So absolute refractive index, it is always greater than 1, but the relative refractive index may be greater than 1 or less than 1. Okay. So what is the statement of Snell's law? The ratio of sine of angle of incidence to the sine of angle of refraction, it is always constant for the given pair of media and for the given wavelength of light used. Okay, so here one very important limitation is there. Suppose the ray of light is incident normally on the plane refracting surface. So in that case, angle of incidence is equal to 0. So after refraction, actually the ray goes undeviated. Okay, after refraction, the ray goes undeviated. That means I is equal to 0, even R is equal to 0. Okay, so in that case, the Snell's law is not valid. Whenever a ray of light that is incident normally on the plane refracting surface. So in that case, angle of incidence is equal to 0. The angle of refraction is equal to 0. So in that case, the Snell's law is not valid. Okay. So what is the meaning of refraction of light? So refraction of light means the phenomenon of bending of light ray. So the phenomenon of bending of light ray when it travels from one medium to another medium of different optical density. So the first law of refraction of light, the incident ray, refracted ray and normal at point of incidence all lie in the same plane. The second one, the ratio of sine of angle of incidence to the sine of angle of refraction. It is always constant for the given pair of media and for the given wavelength of light used. Okay.